Hey guys, I'm Amit Kumar and welcome to this video in which we are going to talk about some example programs. This is part 1. So example program number 1. Write an Apex class with a method and pass a number as the parameter. Print whether the number is a prime number or not. So we know that a prime number is a number which is either divisible by 1 or by itself, and there is no other number that can divide. So let's create a program for it. So guys, here we are on our developer console with our prime number program, and this is very simple program where we have accepted the number as the parameter of the check method, and here we have created a count variable to count how many numbers are there that can divide that specific number. So I'm running a loop starting from 1 up to that number itself, which is passed as parameter, incrementing 1 at a time. And here I'm just checking out whether this loop counter can divide the number or not. If the number is divisible by the loop counter, I'm just incrementing the value of count. So after this loop, I'm just checking out the value of count. We know that for a prime number, there can be only two possible divisors, that are 1 and the number itself. So that's what we are checking out here. If the count is equals to 2, definitely number is a prime number. Otherwise, number is not a prime number. So now let's run this program and check out whether it's working or not. So right now I call this check method of prime number class by passing in 8, and we know that 8 is not a prime number. So let's click on execute, and you can see it is printing 8 is not a prime number. Now let's run the program again with a prime number this time. So let's suppose 3, and let's check it out, and you can clearly see 3 is a prime number. So this is a very simple program where we are checking out how many divisors are there for that specific number. If the number of divisors is 2 only, definitely the number is a prime number. Otherwise, it's not a prime number. Though this program is working fine, but it is not an efficient way of programming. Now let's suppose we are checking out a number 28. Now we know that 28 is not a prime number, and after dividing it by 2, we will come to know that 28 is not at all prime number. Still, this loop will run for 28 times, and then only it will check and print it is not a prime number, which is definitely not efficient and very much time consuming. So we have an alternate method to do so with the help of break keyword. So let's see an alternative to the same program. Now here is the alternative. Here the rest of the program is same with few exceptions, like now I am not running from 1 and I am not running up to number itself. I have started running it from 2 because I know 1 can divide any number and any number can divide itself. So I will not run this loop for those two cases. Now here in this loop, I am checking whether n1 can divide num or not. And if n1 can divide the num, definitely I am breaking the loop. So if any non-prime number is there, definitely it's going to divide it, and as soon as it's going to divide it, it will break the loop. But in case if I am passing a prime number, this whole loop will run and this break will not execute even for once. And after this loop, I am checking out, because when this loop will terminate normally and not with the break statement, the value of n1 will be equal to value of num. That is the case when this loop will end. That is the condition which I have provided here. So that's what I am checking out after this loop. I am checking out whether n1 is equals to num or not. If n1 is equals to num, that means break has not been executed for once and loop is terminated normally, and definitely it's a prime number. But if num and n1 are not equal, that means break have been executed, loop is not terminated normally, and it is not a prime number. One more point of caution is you cannot declare n1 at the time of initialization as we have done in the last program. The reason is, if we will try to declare n1 over here, then the scope of this n1 will be up to this loop only, and you cannot check this condition because the scope of n1 will be ended after this loop and n1 cannot be accessed outside the loop. That's why we have declared this n1 outside the loop so that we can access this n1 outside the loop as well. So let's check this program. And now I am calling the check method of prime number 2 class with the value 3, and definitely it's a prime number, and hence you get the output 3 is a prime number. So this one is a more efficient way of finding out the prime number program. Example program 2. Write an Apex class with a method and pass 2 numbers as parameter. Create a list and store all the prime numbers between these numbers. And definitely we have to print that list as well. So let's see the program. So guys, here is the program. You can see I have passed 2 numbers as parameter named as num1 and num2, and here in the program I have find out the maximum and minimum out of those 2 numbers with the help of math.min and math.max. I have also created a list of integer known as numbers where I will store all the prime numbers within this range. This loop is running from starting number till ending number, and here I have created an n1 variable. Now this n1 will run from 2 to less than number, and every time I am incrementing n1 by 1, I am dividing num by n1 and checking whether n1 can divide num or not. So this certain logic of finding out the prime number is as like as the previous program. But here when the number is prime number, or in other words when n1 is equals to num, I am storing that number inside this numbers list. I am not printing whether the number is prime or not. If the number is prime, I am storing it inside the list. And after these 2 loops, or after this nested loop, I am printing prime numbers between starting number and ending numbers r and the list. So let's see the output. So I'm running this program by calling the show method and passing 1 and 20, and it will print all the prime numbers between 1 and 20. So guys, you can clearly see prime numbers between 1 and 20 are 2, 3, 5, 7, 11, 13, 17 and 19. So this program is working fine. Example program 3. Write an Apex class with a method and pass 2 numbers as parameters. Create a list and store all the palindrome numbers between these numbers. A number is a palindrome number that when read in reverse order is the same as in the right order. For example, 1221, 1221 is a palindrome number because the reverse of the number is the same itself. Now in this program we have to print all the palindrome numbers within a range. So let's write the program. So guys, here is the program. You can clearly see I have passed 2 numbers as parameter. I have find out the minimum and maximum of it and stored it in starting number and ending number respectively. I have created a list of integers for storing all the palindrome numbers. I am running an outer loop over here from the starting number till the ending number, incrementing 1 at a time. And then here is the logic of finding out the reverse of the number, and we have already seen this logic in one of our example earlier where we are finding out the reverse of it. I have created a temporary variable so that the original number should not change and we can check the original number with the reverse of it. So after finding out the reverse, I am checking out whether the number is equals to reverse or not. If the number is equals to reverse of the number, definitely we are storing it inside the list. And finally, after all this nesting of loop, I am printing the palindrome numbers within the range. So let's see the output of this program. So you can see I am calling the show method of the palindrome numbers class by passing in 100 and 200, and it will print all the palindrome numbers between 100 and 200. So let's click on execute. And here you can see these are all the palindrome numbers between 100 and 200, and they are same. You can see they are same. The reverse and the original number are same. So guys, that marks the end of this video. See you soon in the next video. Till then, thank you and take care.